I'm sorry to say I don't have a word of Polish, but what I want to talk about today is a problem which is in English, which is that adaptation has several different meanings, and these different meanings cause great problems. Some people, when they talk about adaptation, meaning in the physiological sense of the waning of a responsiveness of a sense organ. So that's, I mean, not the meaning that I'm going to talk about, but that's what physiologists mean. They might also mean a response to a changed environment, and I'm not going to talk about that either. What I am going to talk about is adaptation in the sense of a feature which is well matched to the environment. There's a fit between that feature and the environment. But there's another sense in which I should all talk about, which is the process by which the adaptive state is achieved. So we have, on the one hand, a state definition, namely the feature which is well matched to the environment. On the other hand, we have a meaning which is in terms of process, by which the adaptive state is achieved. And those two meanings often get confused, as you'll see. Now, in the late 18th century and early 19th century, there was an English clergyman called William Paley who wrote a book called Natural Theology, which was widely read by intellectuals at that time. And in this book, Paley, actually, he was a very good naturalist, and he explained the adaptations of animals and plants to their environment in terms of there being a creator. So what Paley did was take something like the mole, and in his book he says, the feet of the mole are made for digging, the neck, the nose, the eyes, ears, and skin are peculiarly adapted to an underground life. And in this sense, he's using adaptation in the sense of a fit between the animal's characteristics and the environment in which it lives. Now, of course, Paley thought this was a product of a creator, and he said, supposing you are going on a walk in the mountains, and suddenly you see something on the path like that, and you look at it more closely, it turns out to be a watch. And Paley said, it's inconceivable this would arrive by chance. It has to be due to some kind of intelligence. And of course, I mean, what Paley meant by that was that the intelligence came from an intelligent creator. And here you take this wonderful picture from the Sistine Chapel, and it's God on the right informing human beings about how things are, and in fact creating everything that's in the world. Now, I mean, you don't have to believe that, I don't, but I mean, if you have a creator, then you have to have somebody who creates the creator, and you have to have a creator of the creator, and so on. You have an infinite regress back to a Big Bang. I mean, there was a problem always about that idea, and that didn't trouble Paley, of course. Now, when Darwin read Paley, he was impressed by Paley's descriptions of the natural world, and he was gradually collecting material which was going to be published in a big book. And then he got a letter from Alfred Russel Wallace setting out the same ideas that he had about how things come to be adapted. And then they published at the same time. And the idea was that there's variation in the world, there's differential survival and reproductive success of the various types of variation, and then there's some means of inheritance of that, of the ones that survive, so that what Charles Darwin and Alfred Russel Wallace produced was a mechanism by which adaptation could arise. So, I mean, if you imagine two rabbits like this, one rabbit is much more conspicuous than the other, and so the one that's better adapted to its environment is the one that'll be lifted up by the hand of selection, and that'll be the one that's more likely to survive and reproduce. So the way in which this was conceived, and this is still a way in which people think about it, but it's no longer modern. It was an idea that came in the 1930s, putting together Darwinian ideas with those of what was known about genetics. And the idea was that you have a variety of phenotypes derived from genes. Some of them don't work, some of them don't survive. The one that does survive then reproduces and then will generate a new set of organisms with that genotype. And that is how you get evolutionary change taking place. And so on this conception, and I should emphasize this conception is changing, but on this conception, evolution involves changes in gene frequencies. Now that's the old orthodoxy, and I'm going to criticize that, of course, because I don't think it's entirely right. But nonetheless, that was the notion that people had, that you have variation, differential survival, and reproductive success, and then that generates the evolutionary change. Now, much more recently, the ethologist Nico Tinbergen said that there are various ways in which you can think about any organism, and you can ask questions about it. You can say, how is it controlled? What is the nature of the mechanism? And you can ask how it develops. And you can ask a question about why. And you can say, why did it evolve in the way it did? Or what is its utility? What's it doing for the organism now? And these distinctions are now very helpful in thinking about not only animal behavior, but about human behavior. These are different questions, and one is not the same as the other, obviously, and they're really helpful in trying to understand the question of adaptation. Now, thinking about utility, sometimes people use the word function. And function can obviously mean various things again, like adaptation. It can mean a social gathering. A function could be a party. It could mean a mathematical relationship. It could mean how does it work? Or it could mean what is its current use? What is its current utility? Now, you can think about that if you take something a well-known object, and you can say design, which we see in our tools, can be derived in many different ways. And so, I mean, if you take a corkscrew or various other ways of getting into the bottle, there's one function, but there are many different methods. And the one up in the top right-hand corner would involve pushing the needle inside the cork, and then you either pump it or have compressed air, which is pumped into the bottle, and then the cork comes out. It doesn't always come out, though. Sometimes the bottle explodes. And that particular technique of opening bottles has gone extinct. The one in the bottom right-hand corner is sometimes known in England as the butler's friend, because we can put those two prongs down the side of the cork, remove the cork, and take a little drink, and then put the cork back again, and nobody knows you've had a drink, or at least, unless you measure it very carefully. Anyway, the point about this is that all these different ways of getting into a bottle all serve the same function. They're all serving the common utility of getting a cork out of a bottle. Of course, actually, this was before screw-top, so you don't have to use them these days. Anyway, now thinking about it in this way, in the UK, we used to have, still do in some parts of the country, bottles of milk put out on the doorstep of the house by the milkman early in the morning. And a little bird called the blue tit quickly discovered that they could go down to the milk, tear off the top, and get the cream at the top of the milk. So here you see one of these tits tearing off the top and then getting the cream from the bottle. And of course, in a cold winter, that makes a very, very big difference. Now, the point about this is that this particular bit of behavior has arisen not by a slow evolutionary process. It arose quite quickly, in fact. And in 1939, the number of places where people saw this was recorded. And you can see the little black dots on the picture of England show where it was recorded. And then 8 years later, you can see how it spread. And so what's happened here is that the utility of getting into a bottle and getting the cream has spread, in this case, by tits copying each other. There was one very clever tit, presumably at some point, which discovered this, and then others see it, and then they copy it. So this is not a process which has resulted from evolution in the past. It's something which has happened in the recent present. And that's an important point to remember. Now, Konrad Lorenz, who like Nico Tinbergen, got a Nobel Prize for ethology, he had a way of thinking about behavior, which was that the genes gave rise to instinct, and the environment gave rise to acquired behavior. So he had in his mind a notion of a dichotomy between two kinds of behavior, instinct and acquired behavior. And that's still, you still find people thinking like that. They still think that, some people do anyway, not me, but people still think that you can actually divide up behavior in this way. Now, when we talk about innateness or instinctive behavior, it turns out there are many different ways in which people talk about it. And some of them mean that the behavior is present at birth or at a particular stage of development. And that actually is the strict meaning of innate in born. And then others say that what they mean by it is not learnt. And that was actually what Lorenz meant. Then others say that it's genetic, or it's a highly heritable behavior. And sometimes it's used as, for a meaning of this kind, namely adapted during evolution. And we can go on. Sometimes it's used for behavior which develops before there's a function. So if you look at ducklings, they will turn around and preen a little pimple on their back, which is actually going to become an oil gland. But when they do it, the gland isn't working. It's a non-functional gland, but the behavior is already there. So the behavior develops even though there's no function. And some people mean by innateness, it's shared by all members of the species, or the same species in the same sex and the same age group. So yet another meaning. And then some others will mean that it's part of a behavioral system, like hunger, like eating, or like sexual behavior, or like cleaning the body. So it's, in that sense, it's defined in that way. And more recently, people have talked about it in terms of behavior which is controlled by a specialized neural module. It's specific to a particular domain, and it's informationally encapsulated. And then finally, and this is one meaning which is commonly used in developmental biology, it means it's developmentally robust. And in some terminology, it means it's well canalized. It's resistant to environment. So we have all these different meanings. And the question is, do they all actually map onto each other? I mean, is it the case that there's a unitary type of behavior which has all these meanings applied to it? And the answer is no, it's not true. So if we go back to Lawrence, Lawrence was famous for discovery, or at least making famous, a process called behavioural imprinting. And this is a process by which, in this case, geese will respond socially to the first moving thing they see, which in this case was Lawrence's head. And they were imprinted on Lawrence and treated him as though he was a member of their own species. And this happens early in life and is a very robust mechanism. But the point about this is that this is a behavior which is well adapted during evolution, but nonetheless involves learning. So here we see one meaning breaking apart. If you look at the migration of starlings, which are common enough in Europe, what you find is that if you look at a map of Europe and you take starlings from the north of Europe, what happens in the autumn is that the starlings fly off in a southwesterly direction like that. And when they get to the Netherlands, they change their course and they start to fly west like that into the UK and into Ireland. Now, what was done in an experiment was to take the young of starlings, take them away from their parents, and allow them to fly on their own without their parents. And they perfectly successfully fly off in a southwesterly direction. But when they get to the Netherlands, they don't change their course. They go on in a southwesterly direction and end up in France, which is bad news. So what happens here is that the starlings have, in their first winter, when they migrate for the first time, they do what their parents do and learn from the experience, and so change their course as a result of migrating with their parents. If they don't migrate with their parents, then they don't learn this, and they go straight on in a southwesterly direction. So you see here something which is highly adaptable to begin with, but then is modified by a subsequent experience. And we have many, many examples of this. So I mean, here's a beautiful eagle called the osprey, which catches fish from lakes. And what the osprey does is it dives down and will snatch with its talons a fish. But this is a skill, and it's a skill which takes them several years to develop. They have some of the right behavior patterns, but they don't have the detailed skill which enables them to do this. And many of them die in their first year because they don't acquire the full skill. They go through the process of snatching at things, but they don't get the details right, so they don't catch fish. And they can't breed until they can get this skill. So here's something, again, like the starlings, they do it roughly right, but not quite right, and they need to acquire that skill. And if they don't acquire that skill, they either die, or at least they can't breed. Now, if you take another example from our own species, all babies, or pretty well all babies, born at full term, start to smile at about 5 to 6 weeks. And the interesting thing is that blind babies do it as well. You don't have to be able to see in order to start smiling. And so it's a very spontaneous behavior, which comes in pretty well at the same time in all people. All of us would do this at 5 to 6 weeks. Now, here again, it depends an awful lot on what happens later on, how you subsequently smile. So here's the Prime Minister of England, of Great Britain, giving a rather inhibited smile. Here's the Emperor of Japan giving a rather inhibited smile. Here's Nicolas Sarkozy giving a sort of rather anxious smile, I think, but before he lost the presidency. And here's President Obama giving a very open smile, very characteristic of the United States. Now, what is really interesting is that here is a blind man, and you can see it doesn't look like the others at all. It's a rather stereotyped smile. And what you see in this example is that the smile, which starts off in a very spontaneous, stereotyped way to begin with, then can be changed by the culture and the social history of the person concerned. And the blind person, not getting any, any feedback, does smile in a different way. So all these examples of where something starts off and then gets changed by experience. Now, here's another very beautiful experiment done on babies shortly after birth, and they will suck at a teat very readily and at a particular rate. So what you can do is you can play to the baby the mother's voice, and if it increases the rate of sucking, then it hears the mother's voice. If it sucks at a lower rate, it hears another voice. And what the babies do is very quickly, they learn to suck at the higher rate in order to hear the mother's voice. And being good scientists, the people who did this work repeated it with another group of babies where they had to suck at a lower rate to hear the mother's voice, and they learned that very quickly. So they are able to learn about the mother's voice before they're born, and then acquire a strong preference for their mother's voice. Now, the people who did this experiment did something even more remarkable. What they did was to get the mother of another lot of babies to read a story for the last 3 months of her pregnancy. So she read the story every day to her unborn child. And then when the baby was born, the same design was used. But in this case, what happened was the baby had to suck, it changed the rate of sucking to hear the familiar story. And if their mother read an unfamiliar story, they didn't like it. They showed a strong preference for the story that they'd heard before birth for the previous 3 months before they were born. And again, they did the control, which was so that they would change their rate of sucking to hear the familiar story. So what we see here is something which appears at birth, but is dependent on the child's experience before birth. So under one definition of innateness, the preference is present at birth, but it's clearly dependent on the experience before birth. Now, there's various aspects to, I could give many other examples like that, but what we learn from all this is that all those different definitions of innateness don't hang together. They actually refer to different things which are not necessarily correlated with each other. Now, if we take the orthodoxy of Neo-Darwinism, it's essentially saying that the organism is passive in evolution. It's not playing any role whatsoever. It depends entirely on the variation in the genes. And the second point is that the developmental processes are irrelevant to an understanding of evolution. So these are two key points in the ideas about evolution, which are still part of the orthodoxy for many people. Now, I'm going to argue that the organisms play important roles in the evolution of their descendants, and in many different kinds of ways. So, for example, if the organism is mobile, this can lead to it moving to an environment which it has not been in before, and that can generate new types of characteristics which hadn't been seen in the old environment. And there are some lovely examples of this. Some fish which are normally living in the sea, if they swim up into fresh water, they can change their characteristics. So this then becomes a new characteristic which hadn't been seen before, but now is a result of the fish being mobile. Choice is very important, and we know now, for example, that animals have a very clear choice of mates, and this can drive a process which Darwin was completely familiar with. Darwin called this evolutionary process sexual selection, because the choice actually drives the evolutionary change. There's another process by which the organism can change the environment. For example, I think in Poland you have a lot of beavers, and beavers are very striking because they will cut down trees and create a dam across a river and make a little lake for themselves, and in that lake they'll build a structure which they live in. And what we've seen now in the case of beavers is that beavers have changed their characteristics as a result of the way in which they've changed the environment. So modern beavers now have webbed feet, whereas their ancestors did not have webbed feet. So here's a process by which the animal can change the niche in which it lives. It's called niche construction. And as a result of niche construction, it can then impose new pressures on its descendants, so the descendants change their characteristics. Another process which I think is actually very important is that the adaptability of the organism can drive genetic change. I won't go into this in detail, but what we see is that as a result of responding to a challenge from the environment, the organism can change its behavior, and then those individuals which can express the behavior spontaneously then acquire the edge, which then leads them to do the behavior without having to learn it. And this can then drive subsequent changes in evolution. And then finally, something which I've actually got very interested in recently is that play can open up novel solutions to the environment. Not necessarily at the time when the organism is playing, but maybe it acquires experience which can be used in novel ways later on in its life. And so as a result of that, it effectively becomes more creative, and then some other individuals may then use this new bit of behavior which has been acquired by one individual and make use of it as a form of innovation. And I mean, in humans, we see that people who are quite creative are not necessarily the people who actually implement those ideas. There are two different aspects to the process of innovation: picking up other people's ideas and then using them. Anyway, all of this can generate changes in evolution. So my point is this, that organisms are not passive, they're very active, and all of these things can play an important role in evolution. The other point I want to make, and again challenges the orthodox, is that the current evidence suggests that the conditions of development can radically affect an organism's characteristics, thereby challenging one of the other props of the Neo-Darwinist orthodoxy, that development is irrelevant to an understanding of evolution. And this idea has been given a lot of support by the emergence of a new field called epigenetics. There was my hero really, a man called Conrad Waddington, who emphasized our need to understand the processes of development that underlie the interactions between the developing organism and its environment. And he was the one who called this field epigenetics. And it's very interesting when you look at the papers that have been published over the years. In 1960, which was shortly after Waddington published a famous book called Strategy of the Genes, there were 4 papers published. In 1970, still only 4 papers published, still not really taking off. In 1980, 13 papers in that year alone. In 1990, 48 papers. In 2000, 415, gone up tenfold. And in 2010, 3,577 papers. It's a rapidly expanding field. Most of it, I should say, is taking place at the molecular level. Most of the studies on epigenetics are at the molecular level, but the point that Waddington made was that all aspects of development are important to understanding how organisms acquire their characteristics. When people look at it at the molecular level, what they're talking about is either suppression of genes or activation of genes, which then affects the characteristics of the organism. Now, what we now know is that the way in which genes are being expressed can be transmitted onto the next generation. So here we have a yellow mouse which has got a gene which actually came from a virus, and it made the mice yellow. And you can actually suppress that gene in some animals by feeding supplements to the mother. And they're methyl supplements which actually cause genes to be inhibited. And so on the right-hand side, you can see a brown mouse, which is the offspring of a mother that's been fed the methyl supplement, which suppresses the yellow gene. And what is really important here is that the new type breeds true. So the yellow mice breed yellow mice, and the brown mice breed brown mice. So the characteristic which was acquired in one generation is now being transmitted to the next generation without any further effects on the mother. The gene has been suppressed and then passed on to the next generation. So we're seeing more and more examples of this happening, that genes which are suppressed by various molecular mechanisms, and there are several mechanisms which can do it, can then get transmitted onto the next generation. The gene itself is not changed, it's just suppressed or activated in different cases. So this sort of takes us back to Lamarck in a way, although it's not quite the crude sense in which people talk about Lamarckianism, but what it's saying is you can get inheritance of acquired characteristics, and this gives you one example. There are many more now which are coming into the literature. So this again is changing very much the way we think about the whole process of evolution. And there are many other ways in which inheritance can take place too, which you can get effects on the parents, on the way that genes are being expressed. You can get the epigenetic inheritance, which I've been talking about, you can get legacies in the environment which get inherited, or of course you can get cultural inheritance, which is common enough in humans. I mean, where we inherit the culture of our parents and our society. So there are very different ways in which this can happen. There's also bacteria which we inherit from our mothers, and interestingly, if you're born by caesarean section, you may not get those bacteria, and then you may be more at risk from certain diseases. You're more likely to develop allergies, for example, if you've been born by caesarean section. So again, another form of inheritance. So there are many different kinds of ways in which inheritance can take place. And I think the important point to realize from all this is that development, as we think about it, actually starts before conception. There are very many aspects of our environment which actually influence the way in which we develop our characteristics. So, to conclude all this, what I think we've seen here is that the empirical and conceptual advances which have taken place in the last 20 years, 30 years or so, all of these things require us to take a fresh approach to the issues of how our fit between the environment and ourselves evolves. And so it changes the way we think about adaptation. So that's really the end of what I want to say, but I hope it makes you think a bit about the nature of evolution and also the nature of development. And so there was a famous evolutionary biologist who said, a man called Dobzhansky, who said that nothing in biology makes sense except in the light of evolution. And I'd want to change that and say nothing in biology makes sense except in the light of evolution and development. So on that, thank you all for listening.